My name is Mike Thompson. I'm from AMD. I'm a senior cloud product manager there. So I manage all of AMD's products that go into AWS Cloud. And today I would like to talk to you about how you can do more with less by using AMD processors. You know, it's interesting, a lot of users or a lot of customers don't really consider what processor they're running on, what instance type they're running on. It's sort of the status quo or whatever is most easily available or whatever is at the top of the drop-down menu when you're in the EC2 console making your instance selection. But if that's your approach, there's some significant things that you could be missing out on, and that's what I would like to talk to you about today. And there should be plenty of time for questions at the end of the presentation. And so if you have any, please feel free. I'll stick around for a little while afterwards if you want to talk. And I have one little piece of eye candy that you may be interested in seeing, so please feel free. Okay, so the agenda for today, first we're going to look at AMD in public cloud. We'll look at our cloud processor and portfolio roadmap, and then we'll look at the explosive growth that AMD processors have seen in the data center. This comes as a surprise to a lot of people, especially for those that just run with the status quo or don't even worry about what kind of platform they're running on. And then we'll look at why should you care about AMD in AWS public cloud? Why does processor choice matter? And that comes down to a few things. So we'll look at the strengths of AMD in AWS, and then we'll look into some of the specifics about why AMD and how can you do more with less. And fundamentally, that boils down to leadership performance on these processors, plus their efficiency enables you to run faster and smaller and hence have a lower cost. And especially in these economic uncertain times, saving more on your OpEx can mean some significant things to your workforce. So let's dive in. So an overview of AMD data center products today. We currently have our 4th generation AMD EPYC, what we codename Genoa. I prefer to call it Genoa. Since corporate marketing isn't in the room, I'm not going to say 4th generation AMD EPYC processor every time. I'm going to say Genoa. Genoa is the world's fastest data center CPU. This is measurable. I spent a lot of money over the last couple of months measuring it, and I'll show you some specifics about how is it faster. But that really boils down to this. So this is a 96-core AMD EPYC Genoa. That is what Amazon built their 7th generation EC2 instances out of. And so this is the processor in specific that's the fastest on the planet for the data center, and it's what the 7th generation instances are running off of. It's also extraordinarily energy efficient on both of those points, the performance and the energy efficiency. I'll have some specific data for you today. It's so energy efficient that it actually enables you to do some significant business transformation. It's not just a checkbox on the corporate website anymore, and we'll go into some details about that. And then another unique feature of AMD EPYC processors is silicon-powered confidential computing, which means from the moment the power is turned on in the server, it's possible to validate the processor, the firmware that it's running off of, and the software that gets loaded on top of that. And what's unique about AMD's offering is it's actually possible to protect your data in use. And so we'll go into some details about that today. But that's an overview of AMD in the data center today. So let's have a look at the AMD and AWS partnership. I'm going to start from the left. AWS said this themselves, and I'll show you specifically what they said in a few minutes. But they designed the 7th generation instances based on Genoa to be extraordinarily high performance. So they designed it to be the EC2's best x86 performance and price performance. So the performance per dollar, how much you pay for every bit of performance, is the best on Genoa in all of Amazon EC2. It's possible to do spend optimization on Genoa processors. Through our collaboration with AWS, we've brought 2 generations of processors that you should consider right now that enable you to save between 10% and 50% on your jobs. There's an awful lot of instances available. We have 19 different instance types available worldwide in EC2 across 25 regions and 87 availability zones. So there's broad global availability among a wide range of instance types. There's an instance type that's optimized for whatever workload that you need to run there. And they're very highly available. Not only do we have infrastructure, IaaS infrastructure available across specific instance types, but we also run a lot of AWS services like EMR, ECS, EKS, and whatnot. Today we have 21 AWS services that are running that are powered by AMD EPYC Genoa processors. 12 of those are public knowledge. I'll show you specifically what those are, and a handful of them are not public knowledge today, but they're running under the hood. And in general, you can assume that if you go into one of these services and you don't have a processor selection, because of our performance and because of our cost efficiency, our price performance, that those services are running on AMD. Let's see, what else? If we have any partners in the audience today, we have an awful lot of programs that we can do joint marketing together, from executive events this past year, we sponsored with AWS and Deloitte the PGA Tour, so Pro Golf, the CMAs, the Masters, and we have a lot of joint marketing opportunities, even with customers. If you have some application or some workload that can really benefit from AMD processors, possibly we can do something together to help bring customers to you. And then for partners, we can do the same. And we also have proof of concept and proof of value funding available, where if you're considering moving from, say, Intel to AMD, and you want to make sure that you've done your due diligence, we can fund some proofs of concept, or we can fund proofs of value. You should go to your AMD rep in order to get access to those. You can also go to your AWS rep and ask for access to those, and hopefully we get a chance to work together. And then finally, especially for AWS sellers, we're part of their ISV Accelerate program, which spiffs their sellers, that helps incentivize them to close deals on AMD. So what I'd like to talk about now is specifically what has AWS said about the Genoa generation of processors in EC2. They say they designed them to be the best x86 performance and the best x86 price performance in all of EC2. And they characterize the performance uplift, the generational performance uplift from M6A instances, this is the prior generation on Milan processors, to M7A instances, this is the current generation, this is just rolled out this summer, as a 50% performance uplift. By my measurement, I run an awful lot of benchmarks, and I'm going to show you some of the results from them today. By my measurement, 50% performance uplift is a conservative estimate. And again, I'll show you the specific benchmark results and a bunch of the math that we did around that. So AMD entered the data center space with AWS about 5-6 years ago. In 2017, 2018 is when the first instances based on AMD processors were deployed. And that was a pretty good foothold. And really, we just dipped our toes in the water. Over time, AMD has been making architectural enhancements to our processors, and in addition, working with AWS in order to make sure that the instances, the AWS platforms, unlock the maximum performance potential of these processors. And so generation over generation, the performance gets better and better. And especially over the last 3 years, generation to generation, the gap between fundamentally what Intel is providing on their platforms and what AMD is providing on their platforms is growing. So we had Rome deployed in about the 2019 timeframe. Milan, this is third generation EPYC, was deployed in the 2020-2021 timeframe. And those processors were when AMD's offerings in public cloud, AWS public cloud, really came into their own. They're at least 10% more cost efficient than the Intel counterparts. And if you look at these processors around the world, we have 10% lower hourly cost at equivalent or better performance. So pretty good position in AWS. That performance, and especially the performance per dollar value, significantly increased with Genoa, which was released over this summer. With Genoa, we have the M7A general purpose instance, the R7A memory optimized instance, the C7A compute optimized instance, and the HPC 7A instance, which is meant for tightly coupled workloads in high performance computing. Whereas the prior generation, you take all those labels, flip the number back to 6 for the 6th generation of AWS instances, and those are the Milan instances. Can anyone see the cheat code in those instance names that indicates which instances are AMD? Anyone see the cheat code? I know he knows. The trailing suffix A indicates AMD-powered instances. So if you want to find them, grab your drop-down menu in the console, look for the trailing A in the suffix, and those are AMD-powered instances. Now, so like I said, generation over generation, the performance and the price performance from AMD has been increasing. And you can see that play out in the market share. So rewinding back to the 2020 timeframe and looking at 2 years of run rate, the data that we see in the market, this is something that I pulled from an analyst report, this indicates that AMD EPYC processors in the data center market has increased significantly from about a 7% market share 2 years ago to about a 30% market share today. And so that performance and that price performance is driving users to vote with their dollars, to vote with their instance selection. And that's pretty significant. I've been running products for quite a while. Nominally, it takes an awful lot of effort to get a small amount of market share shift. When I worked for Xilinx, I mean, we would run 2 to 3 year product cycle with all the effort we can get, and if we gained 1% a year versus our competition, we called that pretty good. Here we're looking at 30% basically over the span of 3 years, so pretty significant. Now, why AMD in AWS? It comes down to 4 main pillars: performance, which we've been talking about already. With Genoa, you get up to 2x the performance and faster time to solve by running on AMD EPYC processors. So leadership performance. Those processors come with significant cost efficiency as well. If you migrate your workloads, your x86 workloads from the alternative over to AMD, you get at least 10% cost savings and up to 50% cost savings. The 10% cost savings comes from just the retail cost, and the 50% cost savings comes from performance. And again, we'll go into some details of those a little bit later. And so an awful lot of customers this year, we started seeing this last year, are very concerned with sustainability and environmental friendliness. With the AMD processors, your jobs will be running with 30% less power consumption and 30% lower greenhouse gas emissions versus the alternative x86. Some customers these days, they actually have requirements, they have green requirements that their corporate drives down onto them to make sure that their jobs are sustainable and are saving greenhouse gas emissions, and along with that come cost savings because there's less energy to burn in order to run these data center servers. And then finally, ease of migration. Because our processors are based on the x86 architecture, it's relatively easy to switch between the alternative vendors' x86 processors and AMD's. While I don't mean to trivialize what it can take to port code from one processor to another, it is the x86 architecture. In most cases, it's literally the flip of a switch. You go into your console, you stop your instance, you grab the instance selection drop down, grab one of the instances, select one of the instances with the trailing A for AMD, and relaunch your instance, and you go. It's certainly trivial by comparison to porting from x86 to an alternate architecture, say, than porting to ARM, where you have to refactor your code. Maybe some of it has to be recoded. In comparison to migrating to an entirely different architecture, it's a trivial effort. So CPU choice matters. With price performance leadership, you get new options, new cost optimization options. With the higher performance, you can get a faster runtime at a lower cost, or if you take a flat cost, you get a lot more compute capacity for the same cost. Or finally, you can run in a smaller footprint at the same performance. So in some cases, you can cut your cloud footprint for a given application or a given job by 50% while still maintaining the same application performance that you had had previously. With best-in-class energy efficiency, you get lower operational costs, less greenhouse gas emissions, and net-net, we have 2.6 times the performance per watt versus the alternative x86 processors. And then finally, advanced security. With unique silicon-powered confidential computing, you can protect your data in use. So not only do you protect your data while it's at rest on the disk, very common practice today, or while it's in flight through the network, typically encrypted, very common practice today. What's unique and not common practice today is the ability to protect your data while it's in use by the processor itself, going in and out of memory, flowing through the processor itself. With AMD's SEV SNP feature that's available from AWS, it's possible to protect your data in use. There's no proprietary API. There's no proprietary software associated with the confidential computing from AMD EPYC. The computing x86, you have to use a software API. That security is a software layer which has an impact on performance and locks you into a proprietary API, which typically is not desired. And in addition, it comes with push-button migration. So all you have to do in the EC2 console is find the AMD SEV SNP option and flip it on. With EPYC Genoa, there's minimal to zero impact on performance by turning on the security feature, because the memory address translation requirements are already implemented in the processors in GA. So which AMD EPYC processor is right for you? There's basically two generations of instances in AWS, the 6th generation instances and the 7th generation instances that you should be considering for your processor or for your platform choice today. First on the left, for performance and time-bound applications, the 4th gen Genoa processors are the right processors for you. If you're performance-bound or time-bound, customers that need to maximize the performance of their application or have mission-critical time constraints, for instance, a lot of banks need to run overnight risk calculations to determine how does their portfolio, what risk are they taking entering the market the next day. If those risk calculations don't finish by roughly 7 a.m. New York time, they can't open for business. So that job has to finish. For performance and time-bound applications, C7A, M7A, R7A, and HPC 7A are the right choice for your workloads. Taking this example of the Redis database, running on M7A versus Intel's M7I instances, you get 2.2 times higher performance at 48% lower spend. So double the performance, half the cost. But not all jobs are performance and time-bound. There's some jobs, some applications that need to be always on. They run 24 hours a day, 7 days a week, 365 days a year. You can't do 24 hours any faster. It just has to be running. And there's another class of applications that are not CPU bound. So if they're not bound by the processor performance per se, maybe they're waiting for some network access to finish or for disk access to finish. In cases like that, the CPU itself tends to sit around being idle while it's waiting for the I/O to finish. For those types of applications, they tend to be more concerned with hourly cost optimization. And so for minimized hourly cost, it's the 6th generation of instances from AWS that are the right home for your workloads and applications. So you minimize your hourly cost. And in this case, where we're looking at SpecInt, with the C6A, M6A, R6A, and HPC 6A instances, you can get 5% higher performance at 14% lower spend. In those cases, most of the cost optimization comes from the lower retail cost, the lower hourly cost. So performance and time bound, go with 7th gen AMD instances. If you have always-on applications or they're not CPU performance bound, use the 6th generation instances. So now let's look a little bit more specifically, a little bit more closely at the performance. So here I'm stacking up 2 generations of CPUs from Intel and from AMD. In the gray we have Intel, in the blue we have AMD. And the bottom 2 bars, that's the 6th generation instances, and the top 2 bars, that's the 7th generation instances. And what we're doing here is we're normalizing to the Ice Lake instances. This would be like M6i, as 1x performance, and then the performance as you go up the chart is relative to that baseline 1x. You can see that the latest generation of instance from the alternative x86 vendor with Sapphire Rapids has barely caught up to the performance of AMD's last generation. So latest generation Intel barely caught up to the performance of AMD's prior generation. And then if you look at Genoa, this processor that I'm showing you here, that's the top bar. 3 times the performance of the Ice Lake instances and nearly double the performance of the comparable current instance from Intel. And so processor choice matters. This leadership performance enabled AMD to secure over 300 world records across a wide range of applications, from infrastructure, cloud and virtualization, to business applications, Java being one of the most significant, to engineering and technical computing that are very, very performance intensive, from high performance computing to floating point performance, and on to data management across structured data analytics as well as unstructured data and analytics. So processor choice matters for performance. But here we're looking at spec int. Let's take a look at some benchmarks that are representative of a lot of common workloads across enterprises today. Here we're comparing M7a, a general purpose instance from AMD, to M7i, that's the alternative x86 from Intel. From the front-end web tier to the middle application tier, all the way back to the back-office data tier, there's significantly higher performance from the Genoa-based instances, the Genoa-powered instances. And what I'm showing you here is how much smaller can your jobs run if they're on a Genoa-powered instance, and what cost savings does that translate into? So from FFmpeg, where you're running at about half the cost, you save $380,000 per $1 million spend. Just think, how many employees could that keep employed for a year, especially as we're entering into these, or we're in the middle of these economically uncertain times. And then with Nginx, which is used for web serving as well as some load balancing, you run at about 40% smaller and about 30% lower cost. On to Java, which is a really significant one. Most of my customers and a lot of my partners are asking, hey, you got to come help us with Java, where we can say, you can run on AMD Genoa at 30% smaller footprint, saving 18%. And then the 3 databases, so MySQL at 30% smaller, Microsoft SQL Server at 21% smaller, and that's the worst of all. 21% smaller and 10% lower cost than the alternative x86. And then the best performance comes with Redis, where you can run a 55% smaller footprint because it's 2.2 times the performance and saving nearly 50% of your spend. On average, across all of these popular workloads that you see here, these applications are running on average 37% smaller and at 27% lower cost. We'll get into this in a moment, but think, if you're running that much smaller, for those customers and those companies that really have concern with sustainability, when you're running smaller, in a more efficient processor, a more energy efficient processor, the energy savings compound and the greenhouse gas emissions savings also compound. So not only head-to-head are the processors more efficient and more green from AMD, but because there's so much higher performance, you run with a much smaller footprint, so you're running fewer servers and hence burning less gas. So now let's double click down into that. For the Redis example, this is the same column where I'm saying 55% smaller footprint at 48% lower cost. We run faster, smaller, and hence cheaper. With faster, these are the results of the Redis benchmark that we ran. You can see we're measuring request per second for both get and set operations. So get is like a read, set is like a write. Because we run at a 55% smaller footprint, because we run 55% faster, we run in a much smaller footprint, 55%. So with smaller, if you take that performance and translate it into how many instances do you need to run 100 million get and set requests per second. So same job, 100 million requests per second. With AMD, only takes 26 instances. On Sapphire Rapids, it takes 58 instances. Since you're running so much smaller, the net job cost becomes quite a bit lower. So that's the cheaper one here. You run at 48% lower costs because you're running faster and smaller. That's why it's cheaper. So that's how we did the math to get to these conclusions that you see on this slide here. If you want to dig into any details, I'm only showing the Redis example today, but if you want to dig into any details, please feel free to reach out to me. My LinkedIn profiles at the end of the presentation, or to your AMD rep. Or if you want to go look into the data themselves, I've got performance briefs published. All these numbers are published. If you go to amd.com/AWS, you can get straight to the details, and you can get the performance briefs to review on your own. Okay, so cloud efficiency also matters. Here we're looking at performance per watt. How many watts does it take to run the same job? In this case, we're running spec-int at a 2P rate, and we're looking at what is the performance per watt efficiency that you get from AMD. And you can see here the difference between the Intel and the AMD powered instances is even more stark than you see with the performance. So again, the gray bars being Intel, the blue bars being AMD, the bottom two being the 6th generation, the top two being the 7th generation. You can see the latest and greatest processor from the alternative x86 vendor hasn't even caught up to our last generation. If you compare it head to head, 7th gen to 7th gen, we have over 80% greater energy efficiency, over 80% greater performance per watt. And so for customers that care about this, and especially if they have requirements in the applications that they're taking to cloud, AMD is the best choice for you. And so let's look a little bit more practically about what does that mean in terms of energy costs, and what does it mean in terms of footprint and greenhouse gas emissions. So here we're comparing 7th gen processors from Intel and from AMD. Actually, for us, we would call it 4th gen. The instances would be the 7th gen. So if you run a spec-int for a score of 8,500 for a year, over that year, it cost over $47,000 from the Intel instance, and it cost only just over $21,000 from the AMD instance. That's more than 50% savings by moving from Intel Sapphire Rapids to AMD Genoa. What can you do with those savings? A lot of customers, because they're working on a constrained budget, a fixed budget for a given year, they sometimes run into challenges if they need to grow their deployments in order to serve more customers, or when new workloads come up, such as generative AI this year. If the budget's already allocated, what do? Well, if you flip the switch to come over to AMD, you save an awful lot. You can take those savings and reinvest them in new, novel, value-generating workloads that actually turn into a profit for you. And then if any of you have any requirements to list specific types of sustainability savings, this particular instance is equivalent to taking 5 cars off the road for a year in the United States It's equivalent to saving over 2,800 gallons of gas, which is about 12,000 liters. And also equivalent to not burning 28,000 pounds of coal in the USA, and that's about 12,000 kilograms of coal not burned. So pretty significant savings in practical terms. Now, on to security. Typical practice today, I mentioned this a little bit earlier, are these two boxes that you see on the left. The prevalent security model today, you protect your data at rest by encrypting the data when it's on the disk, and you protect your data while it's in transit or while it's in flight, while it's moving through the network because it's encrypted. Common practice today. What's not common practice today is the ability to protect your data while it's in use. With AMD EPYC, they have this feature called SEV SNP, which starts with a silicon-powered root of trust, meaning as soon as the power is turned on, you can validate the hardware, you can validate the firmware that's loaded on it, and then even after you have your application running on it, you can do attestation to query that your hardware and your environment is still intact and legitimate. And so with AMD SEV SNP, or what we call SEV SNP, you have a unique ability to protect your data in use. AWS Nitro has some really, really good security solutions. I would say that this is a complementary security solution to what Nitro provides, but there are some classes of customers that insist that they can't use software-based security. They need to have silicon-based security so that from the time the server is powered on, they can protect their data in use. Okay, so what are the instances that are out there available for you today? This is a look at the AMD-powered instances. There's a bunch of them. The general purpose instances are M7A, that's the latest, and M6A, which is great for hourly cost optimization. The memory optimized instances are preceded with an R, so R7A and R6A. The compute optimized instances are preceded with a C, C7A and C6A. There's a couple of interesting instances in the middle here for bursting workloads. We have T3A powered by AMD EPYC and G4AD, which is a GPU optimized instance. You should keep your eyes peeled for new GPU instance types powered by AMD. There's nothing to announce today, but we're optimistic that we will achieve more deployments of our novel GPU chips. Then there's the high-performance computing optimized instances with HPC 7A and HPC 6A. And then finally, through the Xilinx acquisition about a year and a half ago, we have F1, which is FPGA as a service. It's an adaptable accelerator SoC that is capable of incredible levels of performance, as well as VT1, which is a video optimized instance. Twitch, for instance, can take advantage of VT1. And I mentioned there's a number of AWS services that are powered by AMD processors, from Snowball to EMR. Twitch is running on AMD products. Elemental and Beanstalk are running on AMD products, Batch, EKS, ECS, GameLift, as well as AppStream. And then there's nearly double that number powered by AMD, but these aren't in the public domain. Well, the knowledge that they're powered by AMD is not in the public domain. The services are. So net, what does that get you? You can do more with less. You get more compute on a smaller footprint. That leads to lower job cost. Or if you need to expand your capacity, you get more compute for the flat cost. So you can run your jobs faster or smaller at lower cost. You can get more cloud resources at flat cost. And if you're eager to protect your data in use, you can leverage EPYC's unique silicon-powered confidential computing. So that's it for me today. Again, my name is Mike Thompson. If you want to get in touch, my LinkedIn profile is right here. If you want to learn more, you can go to amd.com/AWS. And if you